Now we're going to do another example of TOF mass spectrometer. This is from paper 2020. It says TOF mass spectrometer, ions accelerated to the same kinetic energy. The kinetic energy of ions given by this equation here. Then you have all this information here, which is kinetic energy, mass, velocity. And then TOF mass spectrometer, each Krypton ion 84 is accelerated to a kinetic energy of 4.83 times 10 minus 16 joules, and the time of flight is 1.72 times 10 minus 5 seconds. Just get this closer. So calculate the length in meters TOF flight time of flight. So this is a basic question that is quite similar in all the questions. It's a basic one. So what you need to know, first of all, you need to know the formula of kinetic energy, and you also need to know that velocity equals to distance over time. So you need those two equations whenever you do a question like that, okay? So because they give you mass here, so we can use the first information, which is kinetic energy equals 1/2 mv squared. So we have to start by working out the mass first. So we got 84 divided by 6.02 times 10 to the 23, okay? All that divided by 1,000, so you get the answer in kilojoules, because that divided by that gives you in grams, and that then you divide by 1,000, it gives you in kilograms, and not kilojoules, kilograms. So if you have that value there, you end up with 1 point, so if you plot this in your calculator, 1.395 times 10 to the minus 25 kilograms. Now you have the mass of your ion. You can replace on this equation here. So we got the kinetic energy value here that they're giving us, which is this one here. So it'll be 4.83 times 10 minus 16 equals to 1/2 times mass, which is 1.395 times 10 minus 25 kilograms times v squared. So then you got v squared equals to, or you can just v squared equals to 4.83 times 10 minus 16 times 2 there, because you multiply by 2, all that, divided by 1.395 times 10 minus 25. So then you have to put v equals to the root of all that. So you can do exactly the same. Minus 25, which gives you the value of 8.832.797. Okay, so velocity is going to be in meters per second minus 1. Now you got the velocity. Now you can plug in this equation here I've given you. So if you rearrange this equation, find the distance, which is velocity times time. Okay, so you end up with distance equals to 83214.97 times the time, which is, where's the time? The time is this one here, 1.72 times 10 minus 5 seconds, will give you the distance of 1.43 meters. And that's how you solve this question. That's a simple version. So if you do this one, you can do all the others, but this one is the easiest one. I hope that's helpful, and thank you. Just to clarify one thing, I forgot to put times 2 here. Okay, so just to be correct. Thanks. Now we're going to do another question of relative atomic mass of 2020 paper. I'm just going to go and show you how to work this out very quickly. Right. What you need to watch out here for is that instead of being 100%, you got to add all these values together, okay? And all values together is going to be equals to 43. So if you say the relative intensity is 43, because it's 6 plus 1 plus 28 plus 8 equals 43. So if you want to work out relative atomic mass, you do 82 times 6 plus 83 times 1 plus 84 times 28 plus 86 times 8. All that divided by not 100 but 43. Okay, so if you would work out that calculation, it'll give you the relative atomic mass of krypton. Okay, so the question is: a sample krypton is ionized during an electron impact. The mass spectrum is sample krypton as 4 peaks, shown below. Okay, calculate the relative atomic mass of this sample of krypton. Give your answer to 1 decimal place. So the answer to that is going to be 3,615 divided by 43, which equals to 84.1. And that's how you calculate that question. Right, the next one here is from paper 2021, where it says a sample of gene is analyzed in time of flight mass spectrometer. The sample is ionized by electron impact to form 1+ ions. Table 1 shows that about 4 peaks of this spectrum. So you got these 4 peaks shown here. Give the symbol, including the mass number and the ion that reaches the detector first. Calculate the relative atomic mass of the gene and its sample. Give your answer to 1 decimal place. So first thing, the symbol, the ones who reaches to the detector first is the lightest one. Is the one which is the lightest one. So it's going to have the lowest mass. The lowest mass is this one here. So it's a 100 SN 112 plus. Remember, you have to have a charge there, otherwise you won't be able to see in the detector. Then it says calculate relative atomic mass. So how you do this? You do 112. So let me start here. I'll do it in the bottom here. Relative atomic mass is 112 times 22.41 plus 114 times 11.78 plus 117 times 34.97 plus, sorry, I just can't show you that, plus you have 120 times. Now this is to be determined, so all you have to do, you add all those values together and you take 100 from them. Okay, so if you got 100 minus 22.41 plus 11.78 plus 34.97, you're going to end up with the value of 30.84%. So the abundance to be determined is 30.84%. So you multiply this by 30.84. All that divided by 100, because abundance is 100. So you work out relative atomic mass of that, and it should give you 116.5, because they say give answer to 1 decimal place. Thank you. We're going to attempt to do this question 6.5, where it says a sample of xenon has AR of 131.31. The sample consists of 4 isotopes. The abundance of 3 of these isotopes are shown in table 3. The data for one of the isotopes, Xe xenon M, is missing. So this is your table, and use the data to calculate the abundance isotopes. So we need to work out abundance first, and then calculate M, the mass number of xenon. Okay, so the first thing you do, you start adding those values there, because they want to know what's the total abundance. So if you got 28 plus 25 plus 27, it's going to give you 80. So whatever's left over is here. So 100 minus 80 equals 20. So the value of ZE here, M, is 20.0. So once you know that, you can now work out the rest. So we start by setting up the relative atomic mass calculation. So we got AR, we know the AR is 131.1. So we got 131.31 equals to, so we got okay, equals to 129 times 28 plus 131 times 25 plus 132 times 27 plus M times 20. So that we need to find M. All that divided by 100. So the first thing you do, you multiply that value by 100. Sorry, I put 100 there. 100. So it'd be 131.31 times 100. So you got rid of your 100. Okay. Equals to all that value for all that. Plus 132 times 27 plus 20 M. Once you have that, you just rearrange to find M. Okay, so when you find M, if you rearrange this, you find M to be 134. So you got to multiply that, multiply all that, plus that. So you then rearrange to find M. So it'll give you 134 grams per mole minus 1. That's how you work out molecular mass. If you got any trouble with this, just send me a text, a message on my YouTube channel, and then I'll try to go through that again. But basically, you set it up like that, you multiply that by hundreds to get rid of that, and then once you have that figure there, you rearrange everything to find M. So bring it all to this side, divide by 20, you find M. Okay, and M should give you 134. So Xe is 134 here. So this isotope is 134. Thank you.